Hi, I'm Craig. Welcome to Get Smarter and Make Stuff. Well, today we're back in the shop looking at the electronic lead screw. I hope this will be the final update for the project because I believe we're down to one last problem, but I don't know yet. I haven't figured out if what I'm about to do is going to fix the problem, so come along with me. We'll head over to the lathe and make a few modifications and see what we can get done. Alright, we're over here at the bench. I'm going to show you what I plan to do today. So if you recall, I had printed these 3D printed using my SLA printer, which has a very high resolution. These pulleys, one to go on the encoder and one to go on the shaft that comes from, that's powered by the headstock. And they're in a 3-to-2 relationship because that's the relationship between the headstock and the gear that we're attached to get us back to 1-to-1. And the problem is, of course, is that they're slipping. Like when this one would rotate twice, this one would rotate more than 3 times or less than 3 times, not exactly 3 times. And I'll put a link up above to the video where we talk about that. So I think maybe my tooth profile in these was not exactly right, and that the belt was riding up on the teeth and skipping a step every once in a while. So since I couldn't do a good enough job 3D printing these, which is disappointing, I decided to buy some aluminum ones, which I would have done in the first place, but you'll notice that they come with this hub here. And the problem is that I don't have enough room, which is why these are printed like this. There's not enough room in the lathe headstock to fit all the things that need to go in there if we have these on here. Alright, well that's fine. We can certainly machine that off, and I'll do that over at the lathe. But there are 2 other problems as well. One is that this, I believe, is an 8mm bore. This is the one that goes on the encoder, and I think I couldn't find one that had exactly an 8mm bore. It also has a flat here and a hole for a set screw. This guy does have the hole for the set screw, but it's on the hub, so I'm going to probably need to drill a hole in this guy to get it to accept a set screw. Don't really need the flat if I have the set screw. It should be enough to hold onto the shaft. We only don't really need a super death grip on the encoder shaft since it turns quite freely. And then for this one, you'll notice that the bore that we need is larger than the bore that I could find for this one. So we'll have to machine off the hub, bore out the middle, and then this also has a key slot, and so we'll need to get a keyway in this guy. And I thought about different ways of doing that. Including a file would probably work, or a couple things with the mill, but in the end I just went ahead and bought a key set. Actually, let me show you. So I just went on Amazon, and I'll put a link down below to this. It's just a little keyway broaching set. It was, you know, a little bit more than maybe I was hoping to pay, given that this is just a simple little one-time operation, but I figured having a keyway broaching set is probably useful. The one thing I didn't have is the 12mm size that I'm going to need. I have 10, 8, and 6. I've got the 3mm broach. This is a 12mm shaft with a 3mm broach. I do have the 3mm broach. I don't have the 12mm bushing, but that's super easy to get on McMaster car. Didn't cost too much. I mean, it was a substantial portion of the price of this whole kit, but, you know, it was pretty reasonable given how far I'm already into this. So I've never done this before. I actually have an arbor press that I haven't even taken out of the box yet, so we'll get to see me try to do this a little bit later as we get into it. But the first step is going to be to machine off these hubs so that I can actually fit the whole thing in where it needs to go. I'm not sure yet whether the 3-jaw is going to be able to grab this hub as nicely as it needs to. So what I did is, since I had 3D printed these pulleys, I have the rough tooth profile, so I was able to go into Fusion 360 and just make these, which are, they've got the tooth profile on the inside, and then it's just, you know, set up so that we can have 3 of these around the edge of the pulley, and they should, if I get them in right anyway, they should snap into the teeth. They do snap into the teeth. I've already checked this. And what we have now is a place where the 3-jaw can grab onto that, and with the teeth, you can actually hear that, maybe give a little snap. With the teeth being locked in like that, it should allow the lathe to grab onto that well enough for us to turn it. But I think it's probably going to be able to grab the pulley okay. Just want to be careful not to over tighten it, because this is aluminum. It's fairly soft. Don't want to damage the flanges. If I think that might happen, then I've got these, and I've got some of the smaller size for the smaller pulley as well. I also have backups. I bought 2 of each of these, so if I totally mess this up and break one of these, well, I can try again on the next one. Anyway, that's the plan, so we'll start by machining off these hubs over at the lathe. Let me get set up over there and we will do that. Okay, we're over here at the lathe and I've got the larger pulley chucked up in the 3-jaw. There's actually these little notches you probably can't see in the 3-jaw that grab the pulley pretty well. So I think we're okay here. Actually, I just realized I haven't taken the set screws out, so let me grab a wrench and do that real quick so we don't catch on those while we're turning that hub away. Okay, there's one. There's another one in here. By the way, the tape that you see on the 3-jaw is because I was trying to mask it off to allow my tachometer to see only this little bit of reflected tape right here. I was trying to make sure that the revolution, the RPMs on the spindle were matching the readout from the lathe, which they were, and it was the electronic lead screw RPM that was inaccurate, which, as we now know, is because the pulleys were slipping. So, mystery solved there. Alright, I think that's that. Let me just double check that we're tightened up here. Okay, nothing is super critical here in terms of tolerances. I'm just trying to turn that hub off, and then I'll punch a 12mm hole in the middle of the shaft, of the middle of the pulley rather, to accept the 12mm shaft that it needs to go on. So let's go ahead and fire this up. Alright. Touch off. Go to the middle. I'd find better results if I wind out. So let me wind in a little bit here and then pull out. Stop for a second. I'm hearing some chatter. I wonder if we're... No, it seems really solid. Okay, just thought maybe we were... Oh, I see what's happened. We've started to bore into the set screws, which is why I'm hearing a thumping noise. I thought maybe the pulley had gone out of true, but I think we're good. Let's go ahead and fire it back up. Point out that I have taken off my rings and my watch. I've rolled my sleeves up. Safety first. I do have my safety glasses on. You just can't see it. Yeah, cutting smooth again now that we're past the set screws. As usual, aluminum doesn't want to break a chip. Not really critical that we get this surface perfectly flat, but I'll do my best. Should be able to see when we're... Yeah, just gotta kiss it. There we go. And then I'll just do a spring pass all the way out. Haven't changed the dial at all, just pulling it all the way back through. Okay. Pretty good, and actually it looks like the pulley may not have been perfectly flat. Also, it's pretty warm. I didn't use any coolant, probably should have. Not too hot to touch, but it's pretty warm, so it may have changed shape just slightly because of the heat differential between the two faces. Okay, so that's that one. Let's go ahead and pull this out. Oh no, actually, let's bore that while we've got it still chucked up here. So let me go ahead and get set up to do that. First question is, where is my calculator? Okay, so I need a 12mm hole in the middle, which is roughly ½ inch, but if we do ½ inch, that's going to be too big. So let's find out. 12 divided by 25.4 is 0.47 inches, and if we go into 64ths, it's about 30 64ths, which is 15 32nds. So if we were to go down say, well, 15-30 seconds is slightly smaller, so that's probably pretty good. Might go down just a little bit more from that. So we said if we got like a 29/64 drill, then I can bore it from there, because I don't think I have a 12mm reamer. Yeah, so let's go ahead and grab a 29/64 bit, and I'll just measure that with some calipers and make sure that it is in fact short of 12mm, and then I'll also actually do a sanity check on one of these guys. So let me go find a bit, be right back. I guess I'm supposed to call them drills. Apparently they're called drills. I have grown up my entire life calling them drill bits, so I'm probably going to just keep doing that. Alright, so I've got my, well, relatively affordable drill bit set from Harbor Freight. I actually really like this thing. 25/64, 29/64. Alright. Really like this thing. It's pretty cheap. It's got a ton of sizes. I haven't had any problems with quality of cut. And I'm just going to check to make sure that this... So that's a little big. Okay, so... Well, there's a lip on this thing because of the way it printed. I still think this is the right size. Let me check another one of these. You know, it's pretty close. Gosh, I'm wondering. That's so close. I'm going to go ahead and have to measure the shaft that it's actually on, because I would hate to discover that this thing is drilled wrong. Alright, I went ahead and pulled the gear off, since I'm going to take that off anyway to mount the new one, and compared it to the shaft, and I'm just using my fingers here. This is definitely smaller than the shaft, so we are in good shape. I can then bore it out to whatever I need to bore it out to. So let's get the bit put in here, and this is aluminum, so I think I can get away with a single cut. I will turn the speed on the lathe down though. Okay, let's just see how we're doing here. Alright, let's go for it, and I'll use some anchor lube. Just a little lubricant there. Way too fast, obviously. And let's pull this guy out of the way. Okay. Alrighty, and actually I've got my chuck extended. I need to pull that back, or I'm going to have a hard time getting through the thing. Okay, let's bring this up, lock the thing, and go ahead and start cutting. Okay. Looks pretty good. Alright, now to get that thing to 12mm. And is there a good way to do this? I don't think I have. So we said it was 15-30 seconds would be just undersized. Boy, I'm trying to think if I want to go and hit 12mm exactly, or if being oversized just a tiny bit is okay. I don't have a 12mm reamer. I think anyway. I have this set of metric reamers, and the biggest one I have is, sure enough, 10mm. Boy, if we go just... Well, I do have a spare, so if it turns out that this one's messed up, I can go ahead and use the other one. So I do have a spare, so, and they weren't even that expensive, so I messed both of them up. Well, it's not great, but we'll live. Okay, so we said 12mm is 30.2/64. So 31/64 should just get me there. And I could try doing 15-30 seconds. And since the drill would tend to be a little bit oversized, that might work. Let's go the conservative route. Let's go 15-30 seconds and see if we can get it to fit on the shaft. Okay, so get that tightened down. Alright. Give it a little lube, even though it was shrieking like a banshee last time. What the heck? And let's run it up. And this should be a pretty easy cut, obviously, since we're only taking a 64th off. Boy, you can hear this thing is just weak. It bogs down. We're at low RPMs, it doesn't have much torque there, but man, even taking a 64th off, that motor still is working. So, alright. So the question is that guy going to fit on the shaft? And unfortunately, the shaft here is keyed already, so it's a little hard to say, right? Because the key is going to hang up there. But oh, you know, what I do have is that bushing, that 12mm bushing. Yeah, for the keyway. If this fits in, then it just barely does not fit in. So I'm going to say we go up another 64th, because it was a 30.2. So we're short 2/10 of a 64th, if that makes any sense. So if we go up another 64th, we will be 8/10 of a 64th over, which is not much, and hopefully we'll be okay. We'll have the wiggle room that we need in order to get this to work out okay. So let's put away our 15 30-seconds. Let's grab our 31 64ths drill, as I'm told I'm supposed to call these. Don't remember why. Just they're not drill bits, they're drills, I guess. Get that tightened up. And let's go ahead and put a little lube on there again and give this a shot. Okay, well that should definitely be oversized, but hopefully not by much. And of course I set the bushing down somewhere where it is no longer to be found. Yep, no idea where I put the thing. Mine like a steel sieve. There it is. Alright, let's see how we did. Yeah, a little bit of play. I mean, a bit more than I would maybe like. Well, we'll see how it sits on the shaft. I can always do this again and do a bore it out. I think I have a small enough boring bar that would fit in there. Here it is, in fact. Yeah, we should be able to bore that. So let's go ahead and take this guy out. And let me take the hub off the other one, which should be much simpler since it doesn't, since I do have a reamer for that guy. Okay, so here is the smaller of the two, and also has a set screw that I'll need to remove. Let's go ahead and crank this down. And it does just fit nicely in these notches on the 3-jaw. It seemed like that held very well, so pretty happy with that. Okay, did that get in all 3 notches? Tighten it down. Take the key out so I don't start the lathe with the key in, because that would be bad. Don't ask me how I know that. Pull this back a bit. Okay, let's go ahead and use a little WD-40 on this guy. Oh, shoot, almost forgot to take the set screw out again. Don't know if that little guy is hardened or not, but I would rather not try to cut through it. Okay, great. Okay, we should be good to go here. Let's go ahead and just machine that hub off. Alright. Going to run the speed up a bit. It's a carbide tool, so it's going to want to go fast. Seemed to work fine last time. It was tightened down. The handle just flopped around a bit. That is probably pushing it too much. Try to take too heavy of a cut. Don't really want to knock it out of the 3-jaw, so. Got a little teeny lathe. Got to take my time. Looks pretty good. Alright, so that guy, we need to get to whatever the shaft of this thing is, and I believe it's 8 millimeters. No, 6 millimeters. Let me grab my metric reamers here, and these will tell me. So there is my 6 millimeter reamer, and I know that's not going to fit in there because I have a flat in there, but that tells me that that's 6 millimeters. Okay. So currently that is a lot smaller than 6 millimeters. I forget whether it's 4 or 2 or what. But let's do the math and figure out what's going to get us close to, but not quite over 6 millimeters. It's going to be somewhere around 1/4 of an inch, but I think a little less. So 6 divided by 25.4 is 0.23 of an inch times 64. So that's 15/64. So 15/64. So, which makes sense. That's just under 1/4 inch. So where do I have my 15/64. Okay, there's 15/64. And that looks about right, I guess. Let me just check this against the reamer because I want to make sure I didn't round the wrong way. You know, that is really close. I'm going to go down 1 to 7/32. I'd rather try to get this one right on. And yeah, I can feel that that's just a little smaller. That is to say, the 7/32 is just a little smaller. Probably did the math backwards. It's 15.164. If I have that right, is 6 millimeters. So 15/64 should have been slightly smaller, but again, without, I mean, it's a 64th. I think we can go ahead and do that. Let me go ahead and get this guy tightened down. Okay, and slide him up. And let's get a little anchor lube on him. Anchor lube, I like this stuff for tapping. Not tapping, drilling. Tapping as well. Okay, let's go ahead and fire up. A lot slower though. Okay. Yeah, that's cutting real easy. And we're through. Okay. And then let's bust out our 6 millimeter reamer. Get that chucked up. And this should be exactly where we want to be. Again, give him a little help. And off we go. I'm going to slow it down some more. I really don't need to be over speed for this. Yeah, that does not feel like too heavy of a cut. I'm glad I went down. Well, I think that 15/64 was right, but given that we're not straining the reamer, might as well just be on the safe side. Okay. That should be that. We should now have a 6 millimeter bore, which should fit onto the encoder. So, let's make sure that's not hot. Not too bad. Okay. And let me deburr that real quick. Just get a little bit of a chamfer there so we can not have any issues getting onto the encoder shaft. Okay, let me go ahead and take the encoder out here. All right, and this is just actually pressed on at the moment. I thought I don't have a set screw in there. Just even pressing it on was fine. And of course, once again, found it. Amazing. So this should just slide on there. Yes, beautiful. Okay. Yeah, just right. 6 millimeters, really good. All right, that is going to need a set screw. That's not a press fit that we can really do anything with. So I'm going to have to pop a hole in here, which I'm not thrilled about because of the teeth, but do not have room for the the hub at all. So gonna have to do that. All right, want to take a break there and get some lunch, and I come back. I'll get this guy set. Alright, I lied. It's actually been more like a week, 2 weeks I think, since I recorded Not Just After Lunch. And I thought about it a bit, and I really wasn't happy with how the big pulley had turned out with the really loose center. And I think it's actually interesting to understand why that happened, although I'm sure some of you caught that. I have gone ahead and made a new one. I used a boring bar, just bored that to pretty close to 12 millimeters. Very little play in that now, so I think that's going to work well to broach. So let's look back and look where I made my mistake. I'll fire my calculator here. And if you recall, I had tried to figure out what 12 millimeters is. So we divided 12 by 25.4. And sorry, there we go. That's better. And I got this many thousandths, which is kind of where I should have stayed. But I multiplied it by 64. And I said, okay, that's 30.2 64ths, or 15 30-seconds, 15.1 30-seconds, call it. And I said, okay, fine. So I'll drill it out to 15 30-seconds, which I did. And of course, it was too tight. It was undersized by 2/10 of a 64th, which is a very weird unit. This is kind of where I got myself in trouble, though. So what is that 2/10 of a 64th? Let's actually, the number we're interested in is 8/10 of a 64th. So what we have is 8/10 of a 64th. So sorry, let's do this straight this way. Divided by 64 is 12 thousandths. Okay, so 12 thousandths is kind of a lot. If you think in thousandths, you will realize that that was going to be a very, very loose fit, right? That this thing was going to go in here and rattle around, which is the problem that I had. In fact, I think I still have it. I have the reject here. And I don't know if you'll be able to see this very well, but it's quite sloppy in there. And if I'd been thinking in thousandths, I would have said, oh, well, you know, what was that? I forget already, but like 12 thousandths, that's pretty loose. I want something a lot better than that. And I would not have gone up to the next size drill because I would have seen that that was going to be too loose of a fit. But instead, I was thinking in 64ths, like a woodworker. And I thought, well, at 64th, that's not much. Really, when it comes to machining, I've got to get myself to think in the habit, get in the habit of thinking in thousandths of an inch, or thousandths, as we say, and that would have led to a lot better result. But now I've got this set up. I actually went ahead and did another one of these because, unfortunately, when I was trying to put the set screw hole in, I broke a tap off and ruined one of these parts. So I went ahead and turned the hub off another one, and you can maybe just see. I don't know if this is going to come out. You know, focus. If I get focused there. Anyway, I chewed up the teeth just a little bit. Unfortunately, I only have 2 of these, and so this one's got a little bit of a ding in the threads, and the other one's got a broken off tap in there. So hopefully this will be good enough. I think the belt will hold pretty well. One thing I thought that was pretty interesting, and that gives me a little hope, is that if I compare these two, and I know you're not going to be able to see this, but if I look at the teeth on this part that I purchased versus the one I printed, the teeth on my printed part are actually quite a bit bigger. That is to say, if I look in here and look at the tooth profile here, it's very narrow this way. It looks smaller. The teeth look smaller. So I think possibly I'm just missing something on how these needed to be adjusted, and the teeth are too big, and as a result, the belt doesn't grip them as well. It doesn't have enough of a valley for the belt to get it down in there and really give it a good grip. But we'll see. I'm going to go ahead and broach the keyway in this guy, which I think is the last thing we need to do before we can put it onto the lathe and see if it works. Okay, I've got my little Harbor Freight 1-ton arbor press here set up, and I've got my the keyway broach collar, whatever you call that thing in there, my broach in there, and I'm going to go ahead and see if I can shove this guy down through, and I have no idea how deep this is going to wind up making the keyway, so I'll just have to give it a try. It seems to be doing a good job. Just see what we get. Oop, I thought that might happen. It's actually hung up. I actually set this up over a hole in the bench so that the broach can extend down below the bench top, so I can push it all the way through. Hung up there for a second, but that looks like it. Whoop, yep, there's the broach falling through. There it is, and let's have a look here. Okay, so that's obviously not going to be deep enough, so I will need to add some of these shims. Just dropped on the floor. Some of these shims, see that? Yeah. Go behind the slot in the broach. No, not the broach. The broach is the thing with the teeth. This is the bushing. Yes. Names. Let's see, I've never done this before, so I'm sure there's a better way to do what I'm doing. If you happen to know, feel free to leave me a comment. Obviously the teeth face down. Hung up on the edge of the hole again. I'm going to snap that broach one of these times if I'm not careful. Okay. Let's see how we're doing that time. Better. Okay. The big test though is, does it fit onto the shaft? And the answer is, it just about does. I turn it over. Do this so you can see better. Yes. Yeah, I think there's a burr in there somewhere, but I think that's going to go on there. If I just take a little file to it or something, there's something in there that's not quite going all the way on, but man, it's close. That is pretty good, actually. Okay. I think we might have it here. Okay, we're back down here at the lathe, and I've got everything installed up here in the head end. I think we're about ready to see how we're doing. Very, very tight in here as usual, but I think I made everything work. I did actually wind up having to turn a little bit of a recess in one of the pulleys to make it sit flush, the one up here that is on the headstock end of the pulley assembly. But I think we're good to go. Things look like they're turning nicely. I have made a mark here. You can probably just barely see that. I'm going to go ahead and darken that. Maybe you can catch it. I know the light's terrible here. And I'm going to make a mark here on the pulley down here. And what I'm going to do is go ahead and run this thing. And we should see, I'll actually go ahead and run it all the way up. Alright, so that went around a lot of times. And so what we should see is that if I bring this guy around, and so now that mark is vertical, and I don't see the other mark, but that's okay because it is 3 to 2, so we wouldn't necessarily see it on every time. And it looks just right. So, very interesting, very interesting. I think we might be good to go. Let me get the cameras rearranged and chuck up a piece of scrap, and we will see if we can put some threads in something. Alright, I believe we are set up here. I'll go ahead and it's got this, I believe you can see the controls here. Yeah, so let's put it into thread mode, and I'm going to do 12 threads per inch. Got my speed turned way down. Let me go ahead and spin this up. Okay, and let's just touch on, actually we can get a little more speed than that. Okay, so I'm going to watch my dial, which you can't see, and I'm going to turn the speed down because that is going pretty fast for me to catch it. And I'm going to catch number 1 when it comes around, although I think at 12 we can catch any of the numbers. Alright, and let me turn my DRO on so I can capture my positions. Alright, let's wind this out, move back down. Okay, so I am going to go back into my 0, and then I'm going to wind in on the, blanking on the name, the carriage here. I think it's the carriage. Just a few thousandths. And wait for my 1 to come around, catch my 1, and we should see it track exactly in that same groove. Boy, that looks good. Whoops, wrong dial, stupid. Alright, let's have a look there. Let me crank this back out, you'll be able to see it better on the other camera. Yeah, I don't see any cross-threading. That's really good, actually. Let us continue. Get back to 0 on my X. Give it another few thousandths. I think that's about 4 thousandths. And wait for my 1 to come around. Still looks good to me. Okay, rinse and repeat. Have a look at this. You'll see that. Yeah, that looks good, man. No loss of position at all. And one thing I can show you actually is, let me go ahead and run this up here. Make sure I'm disconnected on the carriage. Yep. Cross slide, that's the thing that was escaping me. Let's go ahead and run that up. So, I don't know if you can hear me at all over this, but you'll note that now the RPMs on the electronic lead screw and the RPMs here agree very, very closely, which is good. That indicates that we're not seeing much slipping. Gosh, that is loud. And we should actually be able to see, well, I won't do it right now, but if we went back down to the end here, we would see the gears here are still probably lining up. Maybe we can see it. No, I don't think we can see it, but I'll just check for myself. 1 rotation, 2 rotation. Yeah, it's still exactly on. So I think this is totally a win. Well, I think I'm going to call it good. There's, you know, a couple things I could do. There's a plastic bracket in the end of the that's holding the rotary encoder, and I could redo that in metal. I'm not super thrilled with it. I did 3D print it for expediency, but it seems to be working. But at this point, I'm kind of inclined to say good enough is good enough, especially with the threading test I just did. That was super satisfying. As I said before, the thing's been working for turning for quite some time now, but looks like it's working for threading now too, and the ability to change the thread you're turning to at the push of a button, really nice. Got to thank James Clough a lot for all his work on putting together this project and making it really possible for somebody like me to actually do this. I mean, I'm sure I probably could have done it eventually, but given the number of problems I ran into just implementing, you know, something that somebody had already laid down a track in front of me, I'm sure it would have been quite difficult for me to get all this to right. It would have happened eventually, but probably, if I'm being honest, I think I would have given up and had to come back to it after I acquired some more knowledge in various places. But really happy with how this came out. Have to admit, it was pretty frustrating at times. There was a point today where I was looking for the right size belt and I couldn't find it anywhere. And then when I broke the tap off in one of the pulleys, I was like, oh, man, maybe I should just call it a day. But hey, it's working. Just got to button the end up, maybe neaten the cables up. It's no big deal. going good. Like I said, maybe make a new bracket. So I think that might be the last video in the electronic lead screw series, which is great. Can move on to other things. I have some actually pretty interesting large projects that I want to get to, and some smaller stuff too, for sure. Always playing around, trying things. You know, happy to call this one done. I hope you found it interesting. I mean, I know not everybody has a lathe, and not everybody that has a lathe is interested in, you know, doing an electronic lead screw conversion. But you know, I think maybe people would find it interesting just to see my process and my mistakes, which were many, and kind of follow along. If you did find it interesting, hey, it'd be awesome if you'd click a like, subscribe. Commenting is especially helpful. I personally would just love it if people would say, hey man, I found that really interesting, or hey, dummy, you forgot to do this, or hey, your stick out on that that threading you did was super high, don't do that again, which would be a good thing to call. But anyway, if not, it's all cool. Certainly appreciate you even watching. And I hope maybe some of this has inspired you in your journeys to get smarter and make stuff. If it has, awesome. Have fun no matter what. Thanks for watching.